and is waiting for us, same as an appointment. So we have to take it so right now. So permit me to welcome Dr. Augustine O for the citation. The round of applause for her, please. Thank you very much.
Citation of Dr. Augustine O, Nwajana, University of Greenwich, United Kingdom. Augustine O. Nwajana is a senior member of the Institute of Electrical and Electronic Engineers. He received the Bachelor of Engineering Honors degree in Electrical and Electronic Engineering from Enugu State University of Science and Technology, Nigeria in 2004. He also received a Master of Science with a distinction and a PhD degrees in Electronic Engineering from the University of East London, United Kingdom in 2010 and 2017 respectively. He also received the Research CPD Certificate in Practical Antenna Design from the University of Oxford, United Kingdom in 2019. He was with Siemens AG as telecommunications engineer from 2005 to 2009, where his experience spanned many countries, including the United States of America, United Kingdom, United Arab Emirates, Germany, South Africa, Ghana, and Nigeria. He was also with I present to you today one of our keynote speakers, Dr. Augustine O. Nwajana.
Everyone for the opportunity. Let's start with the Vice Chancellor, Professor Okoli, and the Dean, Faculty of Engineering, Professor Mba. And there are other members of staff at ESUT that I would like to particularly recognize today. Professor Ene, who actually taught me a couple of modules while I was in ESUT. Now, it's exactly 19 years since I left ESUT. I graduated from ESUT in 2004. And everything I've achieved today, I owe it to ESUT because that's where it all started. So I really appreciate the opportunity for me to be able to contribute something, at least as a keynote speaker. Now, there are two colleagues of ESUT that I would like to also recognize. Dr. Okafor is somebody that I've been working with. We've collaborated a couple of editorial work. I also have Dr. Stella Arinze. Though I'm not a kind person, but we've also done some collaborative work for some journals in the USA, in Switzerland, and of course here in the UK. What I would like to share today is a work that is being piloted by one of my students, a PhD student. We're doing something that I think is interesting, and I would like to share it, briefly give an overview of who I am, but of course the citation was read, and I don't think there's need for this, but let's just move on. Okay, so the technical presentation, I'll be talking about hardware design, which is the core of my research. I've been researching in this field for over 10 years now. Now, looking at the title for the conference, I think it will be nice to I forgot to imagine a situation where we don't have to charge our mobile devices. You know, if you think of having a mobile phone and you don't ever have to charge a mobile device, you just carry your phone along and the phone charges itself. This is something that is being looked into. It's being developed, and I have a PhD that is working on it. So we talk about sustainability, which is basically how we live our lives, and at the same time we don't make it difficult for the next generation to also have a successful life here on Earth. So that's basically what sustainability is all about, and we're going to be looking into that. So can I get the next slide, please? Now, so this is basically the summary of what I'm going to discuss today. If you're looking at this slide, you can imagine when you walk along the streets on any part of the world, you realize that we have different mobile devices. For example, the whole way you're still right now, I'm sure 90% of us carry mobile phones. So we all have this arrow of energy that is being wasted. It's being just wasted. So the idea is, how do we harvest that energy? How do we harvest that energy, and the output is what we now rectify, which is boosted, and then we can go through the power management like power dividers to be able to manage the power appropriately as required by your own device. Now, one thing to note here is that the amount of energy we get is basically in milliseconds and in milliwatts and microwatts. That means that gives the challenge. So the challenge will not be as fast as it will be if you plug in your mobile device on the power socket to charge. So this is something we're going to look at. The challenges, of course, they will try to also see the benefit, which you will think at the moment outweighs the challenges. Now, so carrying this device actually leads to sustainability. What does that mean? So, if you don't have to charge your device, you don't need batteries, you are using the average source as an alternative, you use less battery. And if you use less battery, then we protect the environment because we don't need to dispose a lot of batteries. And of course, it's also because effective as we see as we progress. Can we move on next slide, please? Okay, so now we talk about the benefits. Okay, so we rely less on batteries because we are now harvesting the wasteful energy and utilizing it to charge our devices. So that means we spend less amount of battery, we spend less on battery, we protect the environment, we think of integration. If you now have one device, during the work, you don't have to carry your charger around, you don't need to plug in your phone. That means the mobile device is actually self-charging, which means you have perpetual usage of your device without worrying about charging it. Now, the amount of power, as I said earlier on, that we get from this energy conversion is very minute, like milliwatts and microwatts. So for that reason, we have this as a challenge, which I'm going to look at in a few minutes. It's a challenge because you need to perpetually have that device working for you to be able to charge to the amount of power that you need to keep your device active. So then once this is done, then you realize that we have the perpetual wireless power communication. That means your device works continuously without the need to charge as a regular. So the cost is also something that we have to consider. We spend less money on devices like batteries. So can we go to the slide, please? Now, this sounds like magic, but you can't get all this good, the upside benefit outweigh the challenges. So think about the atmospheric changes, the changes in the atmosphere. And if you go back to the last slide, please, if you just stay there for just one more minute, please. The last slide, please. Now, so what we say that
my question is, how will the phone charge without you needing to charge or to connect your charger? Like, how is it going to work? That is just my question.
Nothing to do with the data on your device. It's just the wasteful energy that's going in the atmosphere. You don't go to the device itself. I don't know if that answers your question.
Yes.
Okay.
Please, can I get involved in clarifying something there? When we talk about network interference, which Dr. Augustine has actually explained, this is quite different from the energy harvesting he is actually referring to. He's not talking about data energy. He's talking about just wasteful energy which is out there, and we have quite a lot of them. And government is not even taxing them, just like you have your Bluetooth signal. In this case, you can actually share data with people. In this case, we're talking about the network on its own, which in this case is the microwave, just like not everyone is. So when this energy is harvested, they are basically harvesting that energy and not the data and the energy. So in terms of compatibility, your device is already done in such a way that it can only operate within its own confinement. Just like you have, say for example, in the medical theaters where they tell people to switch off their phone so it doesn't interfere with the medical equipment during operation. So that's the intention that you're having. Having train stations, everything is designed to work on its own. So there is no interference
data and information, yeah.
And information, yeah. So this is just normal, just like you harvesting wind energy. Just the same way we harvest microwave energy.
That's my opinion. Yeah, I have this one here.
Yeah, thank you.
Yeah, I'm from the offer. I don't know, maybe nobody's seen that. My name is Austin Inepa. I happen to be among the 2004 graduates. Austin Brown, which you know, I want to see you. I want to see you again. Thank you, sir. Thank you, sir. The CEO of Starlight Industrial Commission and Services. We're based here in Houston, Texas. And I just evening, just about a couple of hours ago, which sent me a message about this meeting. So I wasn't prepared. I was like, I was left yesterday. You can see I'm coming from the program and I have to join in because I value my people a lot. And even if I can help, I can't help the state to do that. So my question goes to Austin about the challenges you guys encounter because this is in the development stage right now. So we expect to see challenges, happening a better continuous improvement. My question there is, have you guys, have you guys considered designing the cascading amplifier circuit, that you can help to boost the signal, the certain threshold that good enough, large enough to be able to, help out in the charging application that you guys are intended for?
Okay. Thank you for the question. I'll just with my mistakes actually. The thing is, what you need to understand is the particular component that harnesses the harvester energy is the antenna. And the one problem that we have in this area is that antennas are designed to work the particular frequency band. So one antenna cannot work across multiple bands. So what is happening is that you have to have multiple antennas. So if you look at my presentation, I mentioned at the end about looking forward. So we're looking at textile antennas, okay? Textile antenna means you have minor antenna that you can actually attach to the fabric of the clothing. So, again, as Dr. Bruno mentioned earlier on, this energy is basically free. It's just out there like the air and free. We don't see them, but they're just there. So we need to harvest them. So to improve what you almost just mentioned, we need to have multiple antennas to be able to harness as much as possible. Now, when we come to how to boost it, I did mention while making my presentation that we generate the amount of energy is not enough because it's in microwatt and milliwatt, which means we have to make sure that this thing is done continuously. Okay, so that's why I said we're perpetual communication. It's just going to be continuous. And that way, we are agree with you that it's not going to be fast as plugging a mobile device on the wall socket and charging it for 2 hours. Okay, so you don't expect to get an amount of charge. However, if your device is going to be active, it's going to be alive all year round, then you don't have problems with the amount of charge because the energy is not scarce, it's available, it's everywhere. In that form where we are also there, we have more than 95% of our mobile devices. So there's energy flowing around, being wasted. So we're just trying again. So the belief that we're looking at, we need to harness that energy and put it. So yes, your point is important, but thinking about mobility is going to be a problem. So what we need to do is have more antennas rather than thinking of designing other components. Have more antennas which should be able to acquire harness having more energy.
Thank you very much, Dr. White. That's the most we can say. Thank you very much for our online participants.
Years ago, we graduated. Well, what I was saying is this: when you look at battery cells, you have to make them to form hybrid.
Please, thank you very much.
Standing on already established protocols.